Alright, hell yeah. So this video is going to be about guessing. We're going to add vectors, and we're going to have to know angles between vectors. We're going to get components of a vector, and if we knew the components, we want to find the magnitude, and we do that using Pythagorean's theorem. Pythagorean's theorem says that, hey, the sides squared, added, is equal to the hypotenuse squared. Sweet. And so I'm going to use a guessing technique that I've made a couple videos on so far. And this is probably going to be a longer video, but we'll kind of go over what's useful. And it's difficult to guess, because sometimes especially if you're trying to get a more accurate guess, that's almost the worst. It's almost not worth it. Big broad brush guesses, hell yeah, those can be pretty useful. Anyway, so if I know two components of a right triangle, maybe these components are the same. So if both of these components are the same, I'm going to take the largest one, which is either of them, and then add 40%. Because if this is 1 and this is 1, this is 1.41, or the square root of 2, so that's where that 40% comes from. There's only two other numbers that I really care about. I mean, because if we are just using this for a guessing strategy, we can't put too much effort in. So if this number is about 75% or 3/4 of this larger number, well, hell yeah, then I'm going to increase. The hypotenuse is going to be 25% larger than this larger number. And you can see that even how I have drawn it, this length is larger than that length. Okay, but if this number is only half, if I have like even the sign of 30 where this is half, or I guess now this would be less. Now this would be even more than the sine of 30. It would be like a 35-degree triangle where this is 1 and this is 2. What's the hypotenuse? Well, actually, you're just going to choose the largest number and then increase by 10%. What's 10% of 2? 0.2. So this is going to be 2.2. And this is an angle of like probably about 35 or something. And you can see that, whoa, this value is basically this value. Is 2.2, was that even worth it to do? So anything less than this number being less than a half of this, we're just saying who cares, it's just this larger value. So cool. Alright, so this one, kind of interesting. We're adding up the tensions of three forces. It says the resultant of those have to add up to 500. You know what I mean? So, cool. Like if this one, and then sometimes just talking your way through, like making the problem like way simpler, changing the problem around, so if this said, hey, this was 200 pounds in this direction, and this was 300 pounds in that direction, cool, those would just, 200 pounds in this direction and 200 pounds in that direction, those would cancel out, and then it would maybe, but the resultant force has to be 500. So it wouldn't matter. In that case, if these are actually equal, it wouldn't matter what direction, you know what I mean? Actually, I just came up with an example that's, whoa, that's pretty wild. Like it wouldn't matter what direction this force would be. This force would just have to be 500. It could be in any direction. It would have a magnitude of 500. But let's kind of work through this. The other approximations that I use is if I have a 30-degree triangle where this is 30, if this hypotenuse is 1, this is going to be like a half, this is going to be square root 3 divided by 2. Well, square root 3 divided by 2 is 1.7, 32 or whatever, divided by 2. So it's 0.866. This is a really good number to remember. The cosine of 30, that component is an 86.6% of the hypotenuse. This number is kind of difficult to work with because it's 0.866. It's not a nice decimal. But what I use is a small angle theorem up to a 60-degree triangle. So small angle kind of works for the sine of an angle. So if I look at this angle of 60 degrees, put some sunshine and rays on it, this would be the sine component of 60. And so I'm going to say that this component is just 1. I'm going to say that this is pretty much the same distance as that. Even though it's not, it's 0.866, but rounded to 0.9, rounded to 1. You know what I mean? Kind of close enough, right? And that's going to be very helpful when we do very early guessing. Okay, sweet. So, and this says the first hint is like, hey, take these two vectors, add them, and get a resultant. And then once we do that, then we can, figure out how to add this one. And, yeah. So before we do this method, especially with vectors, drawing a picture is going to be the best way to go. And then one more thing with tension. If these can only have tension, and they're going to be in these three directions, let's say, the resultant has to be in between this sweeping arc. You know what I mean? I can't have these in tension and have the resultant be outside of this. The only way for that to happen is one of these members would have to be in compression. And the opposite is true. If these were three compressive members, I would draw angles this way, and this way. And then this sweep would be all three of these in compression. If all three of these were bars pushing in on this point, well, hell yeah, the resultant vector would be anywhere in between this. So anywhere from here and here would be a combination of some of these members in tension, some of them in compression. But if they're all chains for this problem, they all have to be in tension. And so, but this problem says this angle really could be anything. You know what I mean? Just because this chain is in between these two, and it just works out that it will be to make this problem do what it wants us to do. Sure, this angle is going to be in between, but this problem is also set up that it doesn't matter where you place this chain. You could place this chain. I guess physical restrictions, you wouldn't be able to place it like if this is 30 and it's kind of maxed out, well, you could probably only place it between here, between 30 degrees and then over here. What is that? But anyway, so yeah, 270. Because if this is 60, 60, 120 of a circle, so yeah, you got about 270. So it's always good to kind of walk your way through problems. Now we're going to go over how to draw this out, and that's really the simplest way to kind of show you the solution. Alright, with any vector problems where you're adding, and what we're doing is basically adding. We're saying this is a component, and this is a component of a resultant. You know what I mean? So we can, and these both have a line of action at the same point, and so, and if these were 300 and 200, you know what I mean? By symmetry, the resultant would be halfway in between. So even just right there, that gives me, because like the whole idea is to have like this guess approach. So like you start a problem and you're not writing equations down right away. And so like what can we learn from it? Well, that's why I like to go over the idea if all these are in tension, it's going to be in this direction. So here's the next thing is if both these are 300 or equal, the resultant's going to be exactly halfway in between, just by symmetry, right? So if this one's a little bit higher, hell yeah, the resultant's going to be maybe somewhere closer to it. So we even have that hey, maybe theta is, and then, yeah, let's pick a value, because even the hardest part about like engineering is wanting to do more calculations, you know what I mean, to be like, hey, and try to do them fast. Like, what's this angle? But even just saying that and talking my way through, I kind of already see the answer. It's 90 plus 30. Now, I could mess that up, but that's 120. So we have 120 degrees between these. If these were equal, I would have a 30-degree swap. That's not what the problem asked, though. Problem asked maybe what theta is. So if this is 60, this would be 30. So, hey, so theta is going to be for sure less. So I know hella for this first resultant, theta is less than 30. I don't even know why I'm using this theta. We'll get to that in a second. I'm just assuming maybe this is the first. In the answer in the back of the book, they call the resultant the first resultant. It says, first, find the resultant of the two known forces. That's kind of what we're doing. Sorry for confusing it, that would be this. So anyway, so these two forces are going to have a resultant, and maybe I'm going to call that angle phi. And so I know that phi has to be less than 30 degrees. So even just right there, from a guessing perspective, I was overlapping two concepts. That happens all the time. So yeah, we're going to see how many errors that I make during this. But all right, so now part of the cool part. Cool. So we just use a graphical approach. So we're going to, the best way to do this is do hash marks, like 1, 2. Just get good at kind of hashing. Whoops. So just kind of, just be able to do that kind of consistently, even at, like 45-degree angles, and we'll see how this is going to be useful. Now for this problem, like what are we going to do? We're going to do 300 hashes? No. We're going to do 30? No. 3? Sure. So this one, and this is just rough, so I'm going to go 1, 2, so I'm going to go 1, 2 down, cool, and put a coordinate system here, and hell yeah, and then so this one is going to be 300, so I'm going to go down 200, and then at a 30-degree angle, so here's how I kind of rough in a 30, do a 90-degree, and then divvy it up into thirds. I think that's fairly accurate. Look how accurate that is. And heck yeah. So then I'm going to do this, and now I'm going to go 300. So if this was 1, and then this is where you could actually, get some paper, and, if you would do that, then you could keep doing this, and then you could actually come back to your paper and get a perfect representation of what those units are. And that can be helpful, because, I really don't want to do that because it's just, it's good to be able to be like, hey, 1, 2, 3, 1, 2, 3. I don't know. Would I have gotten there? So hell yeah. So we went 200 down, 300 over. And so here's the point. Here's the origin. And then it says, so if we added this vector to this vector, now our resultant vector is right there. Cool. So here's our resultant one, and this is what they say, the first resultant from those. That's what they call it in the answer sheet. Alright, hell yeah. And now we need to figure out the dimensions of this. We're going to do the same thing. We're going to go 1, 2, I don't know, It looks like 250. So if this was 200, this was 300. Cool. So at least we know, like, hey, this one's 250. Like, what's its angle? Again, we're just going to be guessing. Easiest way to guess is to maybe sweep out a 90 and then divvy it up 3 times. We know this is 30. So hell yeah, maybe at most it's 15. Just doing a really rough guess. So hell yeah, so we have 250 degrees at a 15-degree angle. Cool. And now what we want to know is the resultant has to be 500, and then we're going to add vectors together. So maybe let's clean this picture up. So here's our origin. We're going to be at a 15-degree angle. We're 250, whoops, to here. And we need this resultant to be 500. So we need to add another vector, and we're going to, obviously it's going to be pulled from here. But because they have a line of action, when we add the vectors, we can add them tip to tail. So I can just come right off here, and we still need to make a vector that's 500 in length. So, and the resultant has to be 500. So here's what I could do. I could come in here and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and add a 45. 1, 2, 3, 4, 5. Heck yeah. So anywhere in here is 500 pounds. And so I have to add a vector to get out here. So, this is where the problem could be obvious, and you're just like, oh, I must just add it right here. And then I reach a vector of 500 pounds, and it does what the problem says. Now this is F. And F is the shortest length possible. Cool. Because I could make F down here. So now here's F. It's a little bit bigger. Our resultant vector after adding these is 500. So this is where pictorially these problems are going to be the easiest. And I wouldn't even use graph paper. I would just get used to doing hash marks. I don't know, just to feel it out, because you can set it up, quickly, and then easily set it up again, make your drawing a little bit more sensical to yourself. Cool. So it looks like F is going to be 15 degrees, and it's going to have a magnitude, oh, I don't know. We said this was 250, so I think F's going to have a magnitude of 250. So that answers it. I think the first vector had a magnitude of 250. So I'm going to say R1 had a magnitude of 250. Vector F has a magnitude of 250. And the direction theta is going to be 15 degrees. Okay, hell yeah. So this was a guess, and I got to do this. Because when I go look in the back of the book, what am I expecting? Like if I saw this was 300, or let's say this was 350 and this was, 425. Would I be upset? You know what I mean? And this angle was 45. Well, yeah, I think I would. These two would be off. This one was, whatever I said on that one, that would be okay. So now, this is the hardest part about guessing. It's like, when do you get a smiley face? Like, when do you get a pat yourself on the back that your initial guess was like, hey, halfway decent? I guess it's good to know maybe like what the percent error you think is in your guess. Because I was mentioning this with a commenter that I think a lot of people have a very hard time guessing. Because you don't have the right answer, and even pictorially, oh hell yeah, this is going to be way better than any initial guess that I thought. So let's hold off on this idea of percent error. I'm going to come back around to it. But now what we're going to do is, I think we're going to do this one without doing it graphically. So I'm going to say this has a component 200 down, so I'm going to go there you go. And then because I know this is sine 30, this is going to be half, so it's got a component 150 up. So hell yeah, when you add those two components, we're going to have a 50 down. Cool. And now we need to know this one doesn't have any component this direction, but this one does. And we have the cosine of 30, which would be the sine of 60. And like I said, I'm using sine 60 small angle. So here's the equation that I use. I mean, you would say that, hey, sine 60 is approximately sine of 1 radian. And then you would say sine x is equal to x. So you would say sine of 1 radian is just 1. So that's kind of where we get that. And so we're saying the sine component, sine of 60, should be 0.866 or 86.6% of this hypotenuse. I'm just going to call it 1, but I'm kind of vaguely showing you where I get that. And so and I'm associating 60 degrees with 1 radian. 1 radian is about 57.3 or something. Who cares? It's about 60. Because for sure 30 degrees is for sure way closer to a half a radian. It gets a little bit better. And sine of 30 is 0.5. So there you go. And so so that's kind of my approximations. I'm taking whatever. So let's say I take angle 30. What do I do to 30? I divide it by 60. So that's kind of, I'm saying I'm using small angle up to a 60 degrees. And I can even draw a sine graph, because this is really good. This is probably the most important guesstimation graph you should draw. You should put 3 hashes where this is 0, 30, 60, 90. Cool. And then you're going to draw a straight line all the way up, at a slope of 1, all the way up to 60, and then a flat line from 60 to 90. This is going to be sine of the angle. Where sine of 30 is going to be right at 0.5, and this is going to be 1. So I'm going to say sine of 60 is 1. You know what I mean? Sine of 45 becomes 0.75. It's not 0.707 like usual. But this is how we can get, so then if I have sine of 20, like what would I do there? Well, sine of 20 is just 20 divided by 60. That's 1/3, or 0.33. Hell yeah. So then if I had this ratio of 1 to 0.33, you know what I mean? Where, I'm sorry. If I have a triangle where the hypotenuse is 1 and this side is 0.33, I want to know this angle. So then I just do the opposite. But I keep that 60 in mind. What did we do with the angle? We divided by 60. So I'm just going to multiply this by 60. So 1/3 times 60 is going to be 20 degrees. So hell yeah. So that's probably the fastest way, you know what I mean? 60. 60 is the magic number. You're using small angle up to 60 degrees. Now, the actual sign is going to be like this. So, I mean, you're only going to be a 5% error from like here, and then you're just going to be money. Sure, you might be 15% error, but this is just our initial guess. Who cares? All right, sweet. So that's kind of where this is coming from. And now we're going to do our roughest guess. So again, we have 200 down, 150 up. So we're going to have a resultant of these two of 50 down. This one is 300. But because this component we're just going to estimate is the same, you know what I mean? If we brought down a circle, if this was the radius and we swept out a circle, hell yeah, it'd be right there. And you could just visually guess. You know, that's the other thing about guessing is just like I have a hard time being like, hey, if this is 300, like what's that? I don't know, 280. I mean, you know, just throw out a guess is better. But we're just going to call this 300. We're going to call this sideways component 300. Okay, hell yeah. So now if we take the resultant of here, our angle is going to be down, and now we're going to use this approximation. So half of 30 is 150, and then this is like this is way less than a quarter. I said if this is like half, if this is 150, yeah, hell yeah, we'll kind of care about this. But nah, this is way less than a half, so I'm just saying the resultant is 300. Hell yeah. So now I have a resultant of 300 in this direction. And then the direction is just 50 divided by 300. That's going to be 5 over 30, and that's going to be 1/6. So check this out. So I'm going to have 1/6 as my ratio. What are we going to do? We're going to multiply by 60. Hell yeah, and that's going to give me that angle. So just think, I'm using small angle as a guesstimation up to 60 degrees. That's kind of where that comes from. And so I have this ratio of 60. I mean, and it's really easy to say, hey, sine of 30 degrees is 0.5, just because we know that one from memory. But if we want to use, if we want to find sine of 20, like how do we do that quickly? Well, you could either do this. You could say, you could do factor label. You could be like, hey, I have 20 degrees, and I know that 30 degrees divided by this ratio of 0.5, or I mean, as a proportion, these are equal. 30 degrees is to 1/2, and so this would be like the factor label method. Degrees cancel, and then I have 2/3 of 1/2, and that's going to be 2/6, or 1/3. And so if I have 20 degrees, that ratio is going to be 0.33. But how could I have gotten there faster? Well, just 20 divided by 60. 60 is that magic number that we're saying small angle up to 60. So, cool. And now I could see that I could for sure make a video on like, hey, yeah, 60 is this magic number. I mean, it's small angle up to 60. People don't know when small angle, you know, when sine x isn't equal to x. Like, well, I'm using sine x to 60. For sure, if you continue it past 60, this is what sine x would be. And it's just like, nah. But everything just approaches. It's sine x is equal to x until 60, and then after 60, x is equal to 1. All right, hell yeah. Okay, so all right, so again, we're using this technique to find the resultant of this. So we're going to have a downward component of 50. We're saying this one's 300. So the resultant, based on this being way less than half, is going to be a resultant of 300. Now we're going to try to find this angle. We said it's going to be 5 divided by 30, which is 1/6. And we're just going to multiply that by 60. So we have this angle is going to be 10 degrees. So hell yeah. So that's this was the ratio 1/6 multiplied by 60, we get that degrees. So now we know that this f or this resultant one, the resultant of those two is going to be let's see. Well, it's just going to be an angle of 10 degrees, and it's going to be a magnitude of 300 pounds. Cool. So now what we can do is you know what I mean? Let's just set the angle equal to 0. Like anytime you get a problem, like always throw in 0. You know, you just to see what information pops up. So if I say I'm going to put this force at 0 degrees, so now we're going to have something like this. We're going to have a component that's 50 this way, 300 this way. So now what are we going to add? And we're going to add 0 degrees. So I don't have to add 200 because the resultant would be this way. But basically I do. We're saying that this is so small that I basically need to add 200. Cool. So if I add 200, you know what I mean? The angle is going to be 0. And then my resultant is going to be close to 500. All right, now let's choose something else. So the resultant, so we have basically 300, a small component down 50. So now let's make a component that's like kind of a 45-degree angle. You know, or if this one's 300, let's say well, what should we do? All right, hell yeah. So yeah, let's say this resultant is 500, and it's going to be at a 45-degree angle. And so kind of back up here, if I know the largest value is going to be a multiple of 40%, and this is one that you should know. If both of these are equal, this is going to be the square root of 2, which is 1.4. And then the inverse of this is going to be square root, 1 divided by the square root of 2 is the same thing as square root 2 divided by 2. Because if you rationalize this, you're going to multiply top and bottom. Or, no, that's not true. So, wait, what? Oh. So if this is the square root of 2, square root 2 divided by 2 is, well, if this is 1.4, yeah, the square root divided by 2 is going to be pretty close to 0.7. All right. And what was I getting on that? If this is 500, then these are going to be 70% of that. So these two components have to be 70% of 500. And so the easiest way that I do that from a guesstimation perspective is just using 10% at a time. So if I had a $500 bill at a at a restaurant, my 10% would be 50. And then times 7, that would be 350. So these would have to be 350, and so my resultant vector would have to be 50 this way, and then 300 down. And so so that's going to be kind of a resultant of about 300. Where over here, if I already had a resultant of 300, and to get to 500, I just have to add, this force would just be 200. So this was worse. This was not minimizing that answer. So anyway, but yeah, I'm just kind of showing probably the harder part about guessing is because if you do start to just guess like this, you're going to have to do a lot more calculations. But it is useful because some of these calculations will show you things that you might not have seen otherwise. But this problem in particular is definitely just seeing the fact that, I mean, we did our guesstimations pretty good up to the point that we found that the resultant, R1, the resultant of these two are about a 10-degree angle. And they're going to have a value, what did we say, about 300. So our F is going to be 200 at 10 degrees. So sweet. So that, from the graphical perspective, that's what, let's see, is that what I got the first time around? Oh, yeah. So graphically, we got that the resultant was closer to 250. And so then I went and used this idea that the sine of small angles can be used up to 60. I can just say this is 300, but it's going to be a rougher guess. So it's just fascinating. Typically, when you do guessing, you want to be like guessing like probably worse, but sometimes like just an overall like a guess that you think is the roughest can magically, be very accurate. But definitely pictorially, this is going to be a very, very accurate way of guessing. So what we did here is we got this value to be 300. We got a 10 degree, so we got something different. We got 10 degrees, and then the force was going to be 200. So that's what we got. Okay, so let's see if we can refine our guess from this perspective. So I'm going to be 200 down, and sorry, so that's going to be negative, and then we have 3, and then this component is going to be 150. So I have 150 up, 200 down. That's going to be a resultant of 50 down. Now I need this component more accurate. I know that this is going to be 0.866. So how I do this fast and accurately is I see that this is 0.8 and 0.9. It's somewhere in between 0.8 and 9. And the 66 part is basically about 2/3. So here's how my method. I'm going to take 8. I'm not going to worry about the 0.8, but I'm just going to take 8 times 3, just the first digit here. So 8 times 3 is, well, and then the other thing is, before you get like carried away of like maybe making mistakes, this value, like you should just do that initial guess. Like, hey, this has to be, because you might even make it more or something, but this component has to be less than 300. So my initial guess was 280. So hopefully we get something halfway close to that. All right, so 8 times 3 is 24, and then 9 times 3 is 27. Cool. And then there's what's the range here? We got 4. There's 3 points. I call this points. Kind of 3 digits between 4 and 7. There's going to be 5, 6, 7. There's 3 whole numbers between here. And I need to get to that 2/3. So I'm even going to do a more accurate guess to get as close as possible to 0.866. All right, hell yeah. And so I'm going to say that's 26. The other way to do this is to know that 5/6 is 0.833. This gets pretty close. And is that right? I don't think that's right. Yeah, 5/6 is 0.833. So I could always do 300 times 5/6. 30 divided by 6 just becomes 55s. And we got 250. So right there I got 250. But I think 260, we got 26. And so that's where, when I do this guesstimation, I'm basically just focused on that first number because it makes the multiplication easier. But then if I get a number like 26, I know it's not 26. I know it's 260. That's why I did that initial guess. Hey, this vector, this component is going to be less than 300. I'm guessing 280. I just ran through those calculations, got 260. So, and I think 260 is better guess than 250. But 250, you know what I mean? Seeing that this is 0.866, just multiplying by 5/6, that's a pretty good estimate of cosine 30. All right, so hell yeah. So now we have that. We have a component that's 50 down and 260 this way. All right, sweet. So this is going to be 1/5. So the hypotenuse, we said from this chart, if it's less than a half, I'm just, who cares? We can know better values. If it's a third, I know that's 5%. You know what I mean? If it's a fourth, I know that's 2.5%. If it's 1/5, I know that's 2%. So I could do that. I could say, hey, I do know that if this is 1/5, I'm going to add 2% of this larger number. So 1% is going to be 2.6, or 2% is going to be about 5. So hell yeah, 265. I'm going to say that's fairly accurate, and it's kind of cool. You don't have to pick up your calculator, but you can get fairly accurate answers doing this. All right, hell yeah. So, and I kind of drew my resultant. We had 50 down and then 260 this way. So my resultant should be right there. And then here's the angle that I'm interested in. If this is about 250 and this is 50, my angles, this ratio is going to be, 5/25 or 1/5. It's going to be 0.2. Cool. So, yeah, it's 1/5. And so what do I know about, and it's going to be, is it going to be less than 1/5? Yeah, the denominator is bigger, numerator is smaller. So it's going to be about like, I don't know, less. But 0.2 times 60, well, that's going to be 12 degrees. So 12 degrees, maybe a little less, maybe 11 degrees. So I think my answer is going to be, for this one, is going to be 11 degrees. We have 265, so I need to go 500 minus 265. Yeah, that's brutal. So 532, so 235. So I'm going to say that, so we're getting a little bit better. So R1 was 265, the force was going to be 235, and my angle is 11 degrees. I don't know, but sometimes you luck out on some of those other guesses. Okay, so now we're going to go start to look in the back of the book, but what should we expect? Because the first, when you do guessing, you could be in order, there's order of magnitudes. If the answer is 5, and one order of magnitude by, an order of magnitude typically is, reserved for the tens place. So if I have 10 to the 1, if this is the answer and I get 10 to the 2, well, that's going to be an order of magnitude bigger than 10 to the 1. And so forth. And then 10 to the 0 is 1, 10 to the negative 1 is 0.1. So right here, I'm either going to have 50 or 0.5. That's going to be the sweep. Now, this isn't good. This is actually 2 orders of magnitude. I'm going 10 that way and then 10 that way. So, but I guess that's plus or minus an order of magnitude of 10. So, so if I take 5, well, in order, how do you even write that? An order of magnitude of 10, because it's not just 5 plus 10 and 5 minus 10. So I need to think about the equation on that. All right, hell yeah. So let's walk through this, because there's going to be a 900% error, this way, and only a 90% error this way. I mean, we're real bad, and we're terrible both directions, but it still is an order of magnitude, 2 orders of magnitude from our actual answer if the answer is 5. So maybe, for our problem, hey, if we're 50% error, that might be a good place to start. It will be way less than an order of magnitude of 10, and so let's do it. And so I'm going to take, if 5 is the answer, I want to know what number, so 5 minus what number, and then divided by 5, times 100 is going to give me a 50% error. And so we're just going to do this the other way. So this value is 50, so I'm going to take 50 divided by 100 times 5, and then I'm going to maybe, let's see, multiply both sides by a -1. And so this would become -5 plus my answer, and then I'm going to add this over here. So I'm going to have 5. So 5 minus 250 divided by 100. So 5 minus 25 tenths. So 5 minus 2.5. So we have 2.5 over here. So hell yeah. And I probably should have just seen that. Hey, if the answer is 5, well, we're going to be plus or minus 2.5. Cool. Because if I get 7.5, I'm going to go 7.5 minus 5 divided by 5 times 100. And then I'm going to, if my answer was 2.5, I'm going to go 5 minus 2.5 divided by the actual answer times 100. That's going to be the percent. Okay, so sweet. So we're gonna use that. So it's just whatever value that I thought my answer was. Now we're going to go plus or minus half of this. So 265 divided by 2. I'm going to store that as x. So I'm going to go 265 plus x, 265 minus x. So I'm trying to, yeah, let's see. And so, and I should probably just do this mentally, because that'd be a lot of work just to figure out what do you think Yeah, because if this is my low end, hell yeah. If this was 125, okay. And then if this was half of this is going to be 450. So if my window's in between there, that's going to be a check mark on reality. This is going to be 100 and maybe twice this, or a half, 50% more than this, which is going to be 375. Okay, so that's going to be my check mark on reality. Now this, lowest angle 10, so maybe 5, and then 15, half of that's going to be 7, 15 plus 10 is 25, I don't know, like 23. So there you go. So if the answer in the back of the book is within that range, I'm going to be like, hell yeah. And now I kind of have a range where it's just like, you know what I mean? I can know it's within this range, and hopefully it's close to one of these target values, and I thought my guessing was improving. But keep this in mind that graphically, hey, this might have been pretty darn close to the right answer. But we used pretty good skills to approximate the cosine of 30 degrees. So this is probably fairly accurate. Cool. All right, so let's look in the back of the book. Catch you on the flip side. All right, hell yeah. I don't know if you can see that, so we blew it up, or I just wrote it down. So the answers to this was the resultant of these two forces was going to be 264.6. Hey, we got 265. Hell yeah. It would have been 260, but I knew that if I have a 1/5 ratio, well, that's 2%, you know what I mean? Because I kind of memorized that extra nonsense. And that comes from this. Hey, take the larger number. So we did, and we saw that this was a 1/5. This was 1/5 the larger number. And like I said, but if it's less than a half, who cares? It's just 0. But you can memorize those other ones. 1/3 is 5%. 1/4 is 2.5%. 1/5 is 2%. You know what I mean? 1/10. If it's 1/10, it's not 1%. It's a 0.5%. You know what I mean? So, but anyway, nonsense. There's only about 3 of these. But yeah, it's just kind of interesting when you kind of memorize a guesstimation technique. It's like memorizing a decimal to 3 digits. Should you do that? No. Cosine, just call it 0.9. There's, why would I call it 1? Why am I so freely able to call it 1? But then, I could do this guesstimation of cosine, 3 different ways. I could call it 1, the ratio to be 1. I could say the ratio is 0.9, and then I could finally say the ratios. Well, I could also say the ratio is 0.85, or I'm sorry, 0.83. That's going to be that 5/6. Or I could say the ratio is 0.9 and 0.8 and then 2/3. So there's kind of 3 different guesstimation techniques. And yeah, but when you're going to get a lot of problems with cosine 30. That comes up a ton, so it is good to have a few methods on that. All right, so hell yeah. So this force minimum was going to be 235, and yeah, wow, we stumbled right across it. So, but I mean, we did a very technical. And then what was the degrees? We said 11. It's 10.9. So we kind of, you know what I mean? But guesstimation is, I find, very difficult because your brain hates doing it, and there's a sweet spot for guesstimation. There's like the rough guess. So let's see what our rough guesses were. Because if this was our rough guess, 300, and it was 264, like I said, here's our window. You know what I mean? So I would say that's check mark on reality. This was supposed to be 200, same thing. You know what I mean? What's our error here? So it's just good. So if this was our roughest guess, saying cosine was 1, so if 264.6 was the actual answer, I'm going to store that as x. So I'm going to go 300 minus x divided by x times 100. So this has an error of 13%. And back to that cosine graph, that's what we would expect. You know what I mean? We're approximating like that. And hell yeah, there's about a 15% error accumulated making that approximation. So, cool. But then on the degrees, sometimes when you guesstimate, one guess might be a little bit big, the other guess might be a little small, and you can kind of converge on answers. So that's kind of wild. Where this decimal is actually better than our graphical, because actually graphically it's really hard at a small just to see, hey, what angle is that? Again, do a 90, divvy it up 3 times, and then hell yeah, this is 30. So yeah, that's 15 right there. So, but it's really hard to tell the difference. If this is 30, you know what I mean, halfway is 15, and then you can divvy that up 3 times. So that's kind of that's the technique that I do for angles. So I'm just going to show you that. We'll be done with this video. So it's really easy. That's the easiest thing, is to take a 90, draw kind of like a sun shape, a quarter circle, and then divvy it up 3 times. Don't get in the habit of divvying up half. The second you do that, it's really hard to find that 1/3. Sweet. But once you get the 1/3, hell yeah, then you can, you know, for sure make hashes in between everything. This is 45, this is 36, sorry, these are 15 degrees. Whoa. This is 45, yes, this is 15, 30, 45, 70, if this is 45, 60, 75, 90. Holy Toledo. So if this is 15, then we can divvy it up 3 times. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Alright, sweet. So I've been really enjoying going over guesstimation, but man, it's difficult because you can make a lot of mistakes. Thanks for allowing me to make long videos. They're probably intolerable, but hell yeah, just like everything, you know what I mean? You're just like, I know people have not done this, so I'll make shorter videos on that, or just keep doing this process because it's just very fascinating. Taking a right triangle, and it'd be kind of fun just to take any right triangle, you know what I mean? Throw one out there. I don't know. Well, let's just take the 30-degree triangle. You know what I mean? What do we have here? We have, this is 0.866, and this is 1/2, or 0.5, which also means this is 1.73, and this is 1. So hell yeah. So what's the, like, how much more is this? So half of this is going to be well, 0.8. Yeah, so yeah, 0.866. So and is bigger. So we definitely have bigger. Do you think this is about 1/3? Or no, what am I saying? Alright, this is the tricky thing about guessing, is yeah, you lose your friggin' mind. So sure, this is about half, it's a little bit more. What did we say of a triangle that's about half? Well, it's going to be 10%. So if this is the dimension of my triangle, I'm basically going to add 10%. I know I'm going to add just a touch more, but definitely this would have to be like 3/4 of this. So the other technique that I do is like, hey, start dividing this by half. If this is the larger value, well, half is 0.43. You know what I mean? Well, yeah, so that's fairly close. What's 3/4? Divvy it in half again. That's going to be 0.21. And maybe just add them together, 0.64. So yeah, so it's not 3/4. You know, it's not 25% more. 10%. I don't know. Yeah, so it's but if this is 2/3, then it's on my graph. I don't have that. But if this is 2/3, it's not going to be 10%. It's not going to be 25. I think it's going to be 20%. So let's show you this. We do the square root of 1 plus 0.66 squared. Yeah, it's going to be 20% extra. So sure, it might be 20% more than this, so let's do that. A 10% tip on 0.8 is going to be, well, it's going to be 0.086, and we're going to have twice that, so we're going to have maybe 0.17. Sweet, so I think I'm going to add 0.17 to 0.866, and probably added too much. But 8, 9, 10. Sweet, so we're going to get 10. My guess is 1.036. So hell yeah. So using that guess. But yeah, let's say I just knew this was 10% more. You know what I mean? That's the initial guess. I'm seeing this is about 5. That's where you can get into the weeds if you're like using guesstimation techniques and then trying to improve upon them. Some are not worth it. So if I just see, hey, about half, who cares, move on with life, then I'm going to do a 10% tip. Or I'm just going to do half of this. So that's 0.4. No, I'm going to do 10% of this. I'm sorry. So it's 0.866 and 10% is going to be 0.0866. So cool. I'm going to have, this is 12. 8 and 7 is 15. And I have 0.95. So my answer would be 0.95. The actual answer is 1. So it just kind of shows you some approximation techniques. So cool. Alright, I think I'm done with this one. So thanks for joining me, and that's the video.